Okay, I've got a pretty good number of people in already, so I think we can probably kick things off. So this session today, we're going to be talking about, excuse me, why we love QoE and why this is our focus. Ultimately, this comes down to our sole goal is to help our customers deliver a good experience so that they can be successful. And QoE is ultimately kind of the umbrella for that mission more than anything else. So I'm going to be talking about a little bit about our kind of evolution and history building Perceive in terms of the problems that we've tried to solve from the first ideas we had, and then as we've kind of progressed to knocking off what we think were the biggest barriers to delivering a good experience, especially in fixed wireless. And then we're also going to go a little bit into roadmap, some of the next problems that we're trying to solve. Andy Sid is also here with us. He's our solutions architect. He works with customers to help understand how to deploy Perceive in their network, from data integration to network integration, network topologies, and all that. So we're going to jump into that after we go through the overview, and there'll be lots of opportunity to, we can talk technical about integrations at the end as well. We should have plenty of time for that. So myself, I'm sorry, I didn't introduce myself. I'm Dan Seaman, CPO of Perceive. So what I'm going to talk about today, firstly, is talk a little bit about why I care about quality of experience at all. I'm going to talk about, at a really kind of high thematic level, the problems that cause poor QoE. Some of them are obvious and some of them maybe a little bit less so. I'm going to talk about our evolution of identifying what the major barriers were to delivering a good experience, especially in fixed wireless, and how we've addressed those and the ones we plan to address in the near future. And then again, go into those deployment models and questions at the end. For existing customers, there will be some new stuff here, especially maybe a bit around the roadmap and the things that we're going to work on in the next little while. And for people who aren't customers, we'll be talking again a very big picture, not a ton of deep stuff about our features, but kind of the themes and again, the high level problems that we try to solve. So why care about QoE at all? There's an obvious one and maybe a less obvious one. For the first is happy customers. Every business wants to have happy customers. Happy customers churn less and they call support less. These are all good things for your business. The less obvious one, though, I think, is you can increase the network subscriber capacity. And if you can handle more subscribers, more happy subscribers, probably being the key bit there. If you can handle more happy subscribers in the same network investment, then that's just good for your business. But the key thing here is this needs to be done in a way that isn't artificially reducing demand and other techniques like that are ultimately going to be poor for the subscriber experience or make the service uncompetitive against things like fiber. And so it's really important to take that kind of growing the capacity angle to that. And we'll talk a bunch about that because that's been a very major focus for us over the last 2 years or so. So what are the underlying problems that end up causing a poor customer or subscriber experience and network level experience? I'm going to talk about each of these in a little more detail, but just as an overview. So the first is measuring the experience is hard. We'll talk about why that is. Network congestion, ultimately a busy network, customer is not going to get the throughput they want, but there's actually a more subtle problem there as well related to how the experience degrades very rapidly. And we'll touch on that. And then finally, it's actually very difficult at scale to proactively manage QoE. In terms of like identifying the problems in the network and what you need to fix and how to prioritize them. And that's especially true for RF and especially true for multi-vendor networks when you have multiple tools you would need to look at, or maybe you have a limited number of RF experts. And that's another area that we focused on as well. So taking each of these in turn. Measuring experience is really important, and it's very different than network management tools. Network management tools are focused on elements, not subscribers. So paying SNMP, all things you need to do, you need to know when you have network elements that are up or down, absolutely required. But quality is a different thing. Quality is kind of more of a gray scale. Maybe some people have heard me talk about this before, but it's not just up and down. It's kind of a gradation of, well, how good is it or how bad is it? And this requires a different style of metrics than what you might do if you're just monitoring elements. And then on the scaling side, NMS solutions, especially the commercial ones, tend not to be structured from a price standpoint that they scale well to individual subscribers. Like you typically don't want to have, all 10,000 of your subscribers being pinged by your NMS from a pricing perspective and often a scale perspective as well. So just it's a fundamentally different thing. Network management solutions do not solve that problem of measuring the experience. This one I could talk about all day, and we have long talks on our YouTube channel about this. network congestion is really interesting because we've probably all had this experience where you have a link that's reasonably busy and say call it 90%, and then it goes to 92, 93%, and then all of a sudden the experience is very, very bad. And that's ultimately a congestion collapse is kind of is the right term for that. And that's what these first two little mini charts I have in the first row are showing, where you're adding utilization to the link, that's the x-axis, and you reach this threshold where suddenly latency goes way up and good put goes way down. And again, I think as service providers, we've probably all experienced this. And what's interesting here is this is actually not fundamental. This is basically an implementation detail for oversimplified queuing. And again, in this talk, we're not going to go into too deep into this because we've got a whole other sessions that are an hour long talking about this topic. But it is possible to have that second row where a little bit more link utilization creates a little bit more latency, and a little bit more link utilization creates a little less good put, but it doesn't just suddenly collapse into a very, very poor experience. And maybe I should have defined good put as well. Good put is basically the useful traffic, useful bytes transferred by the network. That's not necessarily the same as throughput because retransmissions in some sense are not very useful. So this is possible, and based on using better queuing techniques, essentially. And the key thing to remember, and we'll come back to this in a little bit, is this isn't just backhaul links or just access points. When you deliver a subscriber a plan, say shaped to 10 megabits per second, they have a virtual link of 10 megabits per second. And this exact same problem happens within that virtual link. And that turns out to be a very big cause of poor QoE, essentially self-congestion within their own plan speed. So we'll talk about that a little bit as well, or how we solve that problem. The third one I mentioned is being proactive on QoE is hard. It's really hard without the right tools because you need to look at multiple vendor tools if you have multiple vendors. If you have the right expertise and you have lots of RF knowledge and you kind of built up a picture in your head of how APs perform, it's possible to do this, but it's very time consuming. And it requires correlating information from many different sources. So usage for subscribers, RF conditions, and a whole bunch of other things that are just kind of difficult to do by one person in their head. And this requires a dimension of overtime analysis as well. Many vendor tools are kind of like snapshots. Like, you open up the AP management tool and you can maybe see the last little while of what the link rates are or something like that. And that's very useful for debugging ops problems. It is not very useful for understanding the overall quality of the network. That requires a much more of a overtime analysis. Doing, one example of that is some of our metrics are actually based on extracting the worst minutes of the day and reporting on those, because that's what people are going to latch onto as the real feel and quality of the network. Maybe a simpler example is if you only look at your throughput at 9 a.m. when you come into the office and think your network's fine and never look at it at 10 p.m., you're probably going to be in trouble, right? And that's slightly oversimplified because it's like one transit link or two transit link versus tens of thousands of subscribers, but kind of the same concept. So managing QoE is just hard at scale of subscribers without the right tools. So for us, quality of experience is much more than just traffic management. Our history, before doing this, we worked building large application-aware traffic management boxes for many years, have a lot of experience of doing that in tier ones and other places, and basically recognize that that's not the real solution. That's only a little part of the solution. You can't ultimately deliver a great experience by arbitrarily limiting traffic. So we've been focused for the last number of years on other areas, which is, again, understanding the QoE and making it better. And so we think that in order to have a kind of complete picture or a complete, QoE solution, there's a few things that are required. You need to have the subscriber experience information and measured in a way that's indicative of the actual customer experience. And we'll talk about how we do that. You need to have deep integration with the underlying access network. So for us, the first thing here is topology. We reach out and we figure out the subscriber topology and the access elements they're attached to. We don't need to be provisioned that. We don't need to get it out of the billing system. We're able to just reach out and gather all that information. Really, really important. And of course, we collect a ton of information. If you've seen our fixed wireless report, if you go to perceive.com, you can download that. That's a snapshot of some of the information we have. We probably understand the real world behavior of access points better than many of the vendors do, because we just see like tens or hundreds of thousands of access points and have very fine-grained data on how they're behaving. And with that information, you can drive proactive quality improvements such that you don't need to do much traffic management. There's kind of two aspects of traffic management too. I mean, the first is optimizing for latency, not just throughput. That's absolutely necessary. We'll talk about that. But the second of arbitrary limiting traffic is just not necessary in most cases. And there's better ways to do that, which we'll touch on the end as well. So for us, this kind of analytics and driving improvements and getting at that kind of flywheel of network improvements is much more important to delivering good quality of experience than limiting traffic. So our evolution is how we've tried to identify and knock off these problems over the last while, or I guess almost 5 years now. We started off by wanting to be able to measure the quality of experience for subscribers. After that, it quickly became apparent with those metrics in place that a lot of the subscriber experience problems were that self-congestion problem that I mentioned. We'll talk about how we solve that. And then with that was in place, we realized a couple of years ago and heard from our customers that even though the QoE metrics were pointing at the problems, they didn't have the tools to proactively solve them. So we bit that off with the scores, which we'll talk a little bit about. And now the things that we're working on right now, the ones that are in italics there, the AP congestion, plan assurance, and then the multi-access stuff I'll touch on as well. Those we believe we've heard from our customers are kind of the next biggest problems, and that's what we're working on. So we'll get to those after we get through the other ones, the first ones. So what do we do to actually understand the quality of experience? We basically measure the traffic for each individual IP address and system, latency, loss, throughput, all those good things. We combine that with our topology knowledge that we have. Again, discovered from the network directly with some priming information from billing systems and stuff. And we use that to understand the quality delivered in various parts of the network. So you can answer questions like which backhauls are overloaded, which APs are overloaded, which individual customers are getting a bad experience. But because this is measured at the traffic level, it actually finds all kinds of interesting things. Things like bad bonded links, something that's set to flow or packet load balancing instead of flow load balancing. We've seen overloaded microticks causing packet loss, and ultimately you dig and find out, that microtick's just completely overloaded. Because it's not looking for any specific cause, it tends to find some surprising things. And we think that this is really the only way you can actually understand the experience. Those kind of subscriber metrics, and again, tied right back to the topology, because it's not actionable without the topology. So that was the first thing we did. And as I mentioned earlier, then we very quickly noticed that subscribers were self-congesting. Within their given plan speed, 10 meg, 20 meg, 50 meg, they were self-congesting and causing their own problems. So you think of many of the cases of where a customer calls in and says, my game's laggy when the kid watches Netflix, or my internet just feels slow. If you've ever gotten those calls and you've looked at the AP and said, well, that AP is not that busy, there's a really good chance, if you don't have smarter shaping, that they're actually self-congesting. Even it can happen on like hundreds of milliseconds basis. It doesn't have to be a flat line on a bandwidth graph. This can happen on very short intervals. And this really just comes down to what I mentioned before about having essentially poor queuing management techniques in that plan enforcement platform. So we looked at that problem and based on, again, some prior history and work, identified FQCODL, which is an RFC standard, as a way to solve this problem. And essentially, we divide the traffic across a whole bunch of virtual queues per subscriber. And by doing that, we're able to isolate those flows and allow the latency to stay low, even when there's a bunch of stuff going on. So those problems, like, again, you're watching Netflix and the game stops, they just go away as long as the network doesn't have other underlying problems. Like if the AP is overloaded, it can't solve that. So we'll get to the AP a little bit later. So that was kind of, call that Perseem 1.2 or something like that. Like not in actual versions, but in terms of our evolution from measuring the traffic to this kind of the main problem we saw was this plan enforcement side. And then a couple of years ago, we were hearing from our customers that we were pointing to them to the problems in the network, especially on the AP side, like which APs had bad subscriber experience, especially from latency perspective and other things. But it was still very hard for them, especially at scale. So anybody who's had a big enough network where one RF expert couldn't do it, for example, that it was really hard to operate at scale. They didn't know, what do I need to go fix? Which specific subscribers do I need to go fix? Which ones are the worst ones? And this is kind of complicated because it's not just a matter of looking at link rates. It requires that kind of over time longitudinal analysis. So what we built, and it took a couple of years, is we built a platform collecting even more metrics than we already had, especially on the access point side. And this allowed us to build some, what I think are some pretty interesting techniques for simplifying this. The inputs to the system are basically the behavior of your specific access points in your network, given the hardware, the configuration, the behavior of the CPEs in the network, combined with this model we're able to build across all of the data collected across all the Perceive customers. And as I mentioned earlier, we have a lot of performance data on how these APs perform, and we know what they should be capable of. And you combine that all together. I say magic, of course, it's not magic, it's math. But that coming out the other side of that is a bunch of very simple numbers that can guide being proactive in the network. So the RF score, which EPs and which subscribers have the worst RF. But again, not as simple as looking at just the link rates. That's just not sufficient. The business value score is pretty interesting. That's a combination of subscribers that have like poor modulation, and they're active when other subscribers are active. So those are the ones that are hurting your airtime the most. Those are the ones you need to go fix to increase capacity in your network. We've done this across basically all of the APs that we support. So Cambium, Ubiquity, a bunch of Mimosa. There's some other ones coming soon, some of the vendors that we don't see quite as much of. But this gives the team kind of one spot to understand like an action list and quality across all of these different vendors. And as you introduce more vendors in your network, that just gets really complicated. More vendors is often a good thing because it gives you more price negotiation and best of breed product for the right solution, but it also adds a lot of complexity, and we're trying to help with that complexity as well. So in this example, you can see there's some scores for 450s, there's some scores for the Rocket 5 AC. The other thing I'll mention is the subscriber capacity. And this kind of follows from the same data-based approach we're taking to these problems, that now that we know what a typical subscriber does in a given network, and we know what the AP is capable of, we're able to convert that back into something as simple as how many subscribers should that AP have, essentially in the current RF conditions. And the example there in the bottom right is there's 3 too many customers on that AP. So I like that one as an example of the power that comes from having a lot of data across a lot of networks. The next problem that we're working on, and this one's pretty imminent, is dealing with AP congestion directly. So the first problem was self-congestion on individual subscribers from a traffic management standpoint. But there is still cases where APs can be overloaded. We've all had this happen. Ideally, we stay ahead of it. We improve the RF conditions. We don't let it get there, but sometimes it's just going to happen. So we built a system that takes a bunch of inputs. So again, our network topology that we discover ourselves, the AP performance, the RF conditions of that AP, the CPE performance, the RF conditions of those individual CPEs, with that big data pool we have of performance across our customers. And we can automatically determine what the downstream rate towards that AP should be to deliver a good experience. And what's neat about this is it flexes. So if you fix the RF conditions, it's going to start to widen that up. And if you get really bad RF conditions, it's going to shrink it down. It's not hyper aggressive because we're trying to solve long-term trends here, not short-term problems like a tree. Well, a tree's a bad example. Like, I don't know, like some short-term interference. This isn't targeting at short-term interference, but long-term trends to maintain a good subscriber experience. So this is running at hundreds of access points today across some of our customers that let us test things like this. And I don't know that we'll quite make WISP America for release, but it will be definitely talking about it and showing it there. And it shouldn't be too much after that. But it is functioning and again, running on, I'm not sure how many hundreds right now of live access points. So that's the next problem we're taking on, very imminent. Sorry, go back there, the automatic AP. The next, the one that we're kind of working on a little bit in parallel, is understanding the network's ability to deliver a plan speed while maintaining a great experience. And this is questions like, can a given AP handle a 50 megabit customer? Or can a subscriber on a given AP be upgraded from a 25 meg plan to a 100 meg plan? Will that actually work? Or how many 25 meg subscribers can we put on a given AP? We're going to present this in a way that's really simple, so non-technical people can understand. There's no sense in trying to talk, airtime to the marketing department. That just doesn't help them, right? They need to have something that's more along their dimensions of how they think in terms of plan rates and subscribers. But what I think is super important here is this is not simple link rate calculations. You can't answer these questions with that. You have to have an understanding of the behavior, of the performance of the AP, and a whole bunch of different things. So the way I like to think about this is there's some implicit clauses in those questions that kind of need to be stated to understand how hard this is. So that example, the first one is can that AP handle another 50 megabit per second customer that behaves like a typical 50 meg customer in my network, and can it still deliver a good experience afterwards? And it's those last two things that makes answering these questions hard. Similarly, could a subscriber on a given AP be upgraded from 25 to 100 megabit, knowing that in my network, the typical 100 megabit subscriber uses somewhat more bandwidth than a 25 meg, but it's not 4 times. It's not even close to linear. Can we do that and still deliver a good quality of experience? So this we're working on as well. This is not WISP America. This is a little bit farther out, but it's kind of the next major thing that'll come after. And then thematically, the next thing we're working on in parallel as well is more of a focus on multi-access. So many of the features inside Perceive are fixed wireless, and that's historically that's the area that we focus the most, and we're not going to stop focusing there. But we're also going to add some focus on other access technologies as well. So like many providers will have multiple access points, so they're already kind of multi-vendor, multiple access point vendors. So they're already dealing with multiple vendor tools. But once you get into a fiber world, you're almost certainly a multi-vendor network. There is really, I don't know of any vendor that is best to breed fixed wireless and fiber. That does not exist yet. Maybe probably never will. So being multi-vendor just adds a lot of complexity. And we think there's a lot of value in being that kind of simplified quality layer across all of them. So everyone in your company doesn't need to learn all the details of fixed wireless and Cambium and Ubiquity, or all the details of fiber and KLX and Adtran. So this is kind of the major theme as we wrap up the plan assurance stuff as well. So for us, our kind of broader vision and view of QoE here is so much more than traffic management. It's understanding where the quality problems are, being able to address them proactively, be proactive, fix the problems before the customer comes and complains about them, or worse, before they leave. Address the very tactical traffic management solution, which is optimizing for latency. Most people, if they get good latency, they'll never even bother to run a speed test. Of course, there's some customers that will run speed test all day long, but they're in the vast majority. And then when necessary, mitigate the problem with traffic management, mitigate congestion with traffic management. I cringe a little bit when I hear people are talking about things like deprioritizing game updates because they're low priority. For a kid that just came home from school, those game updates are the highest priority thing in the world to him. And I think this is just the type of approach that it's been abandoned in other access technologies, and it's not going to help fixed wireless win. We're in a world now for fixed wireless to win. We have to be delivering and talking about delivering more capacity, not putting arbitrary specific limitations in place to try to stay below that AP threshold. What we're doing with that AP congestion thing is we're going to stay below that within the traffic envelope without playing any games about trying to pick on individual applications. And Andy and I could probably go on for some length about our DPI trauma. I sometimes joke, but it's just not necessary anymore, unlike maybe 10, 15 years ago. So our big picture QoE, an ounce of prevention and an ounce of being proactive is worth a pound of mitigation. So proactively manage the network to improve the QoE. And when it's really necessary, mitigate that with traffic management. But traffic management first approaches to QoE are just destined to fail. That is not going to be the long-term strategy to have successful customers and compete against other access technologies. So with that, I'm going to pass it over to Andy to talk a little bit about integration stuff, and then we can circle into deployment questions, roadmap questions, whatever questions people have. So go ahead, Andy.
Great. So we're going to talk a little bit about how we deploy Perseem in an operator network today. There's a few considerations when we are trying to decide where we're going to deploy the element itself, okay? So the first thing is obviously we need to be able to identify a subscriber by their individual IP address. All of the things that we are doing with respect to the traffic are we're identifying topology, we're identifying subscribers strictly by their IP address. So that means that if there are any NAT points in the network, the appliance itself has to sit south of the NAT. Okay. The second consideration is that all of an individual subscriber's traffic should pass through exactly one bridge. So where there are possibilities for traffic asymmetry, that is where an uplink goes one way and a downlink passes through a different one, we want to essentially avoid that situation as much as possible. And the third consideration for us is that traffic should generally not be encapsulated. There's a few exceptions to this. We can handle up to 2 levels of MPLS tagging within it. But if you're running anything like PPPoE, E over IP, VPLS tunnels, we typically don't want to be sitting on a segment that intersects one of those. And with that in mind, there are essentially two basic deployment models for how we deploy Perceive in an operator network. The first one is what we call an inline design. The second one is what we call a switch-centric design. So let's talk a little bit about what those models actually look like. Okay. So in an inline deployment model, Perceive is deployed essentially intersecting a link in between two routers at the head end or at a point of presence in the network. So anywhere that you've got an egress out to internet is typically where we would deploy Perceive. And the topology in this type of model is defined by the physical connections between the devices in the network. So typically, in a network like this, you would have a router that is performing a border function. This would be a NAT point. It would be talking BGP to your upstream. You have another router that would be performing what we would consider to be a core function. So this would be terminating VPLS tunnels, terminating PPPoE, that sort of thing. And potentially, you also have some edge routing down in your access layer. So routing at the tower level to cut down your broadcast domains. Well, this is how we've been building networks for as long as I can remember, at least. It's a very well-known model. Things happen in this hierarchical manner. It's very easy to understand. Okay. There's also a number of disadvantages to deploying your network in this way. The first one is that you're going to be limited by the port density that is available to you on the individual devices. So let's say you've got a router that is passing more than a gig of traffic. And well, you need to be able to you need to increase capacity, but you don't have sufficient port density. So you've run out of ports on the thing. Mismatched port densities, port availability between the individual devices can sometimes prevent you from bonding things together to get increased capacity. The second thing is that upgrades, if you ever needed to replace a piece of equipment in the network, well, the upgrades are not hitless because all of your topology is defined by your physical connections. It also means that replacing a piece of equipment also requires you to unplug stuff. So you're going to have network downtime when you're trying to perform, say, a forklift upgrade of one of the components in your network. And the third disadvantage of this is that in order to build a bypass to go around Perceive, we actually need additional physical ports. Okay. So again, because topology is defined by the physical connections, if I need to have traffic going around Perceive, we also, or any element, any arbitrary element, quite frankly, it requires additional physical ports to be able to bypass the traffic. Okay. So this is how we've been building networks since the beginning of time. It has they're very easily understood, but there are some pretty significant disadvantages to building your network in this way. The second model that we typically see is what we call a switch-centric deployment model. Okay, and in this way, Perceive is deployed in a layer 2 hairpin that's off of a central switch stack. And in this model here, the topology is strictly defined by a VLAN and port isolation configuration on the switch. So rather than relying on the physical interconnects between individual devices, I can now add arbitrary port density by adding to the switch stack. Okay, it simplifies adding capacity by bonding interfaces together, upgrades become hitless because, again, I don't need to rewire the network anymore when I'm replacing something. I can simply plug that new element into the switch, and then all of the topology is defined strictly by VLAN and traffic weighting. So, we just we change over to a higher cost path or lower cost path, and boom, you're in line. So the other thing that we're going to give you here is that going with this type of topology is that we don't need any additional physical ports that are consumed for bypass. Again, because the bypasses can be strictly defined by a VLAN on the physical interface, I don't actually need to occupy any additional ports. So obviously, this is the new school. There's a little bit of a steeper learning curve to be able to understand and maintain this type of network. But if I was building a new network today, this is how I would be building it, right? Is with a stackable switch, which gives me flexibility in how I scale my network. It gives me, flexibility in terms of like when I do need to do my upgrades, how I can engineer the traffic to make sure that there's no downtime. And that's pretty much it in terms of the deployment models. We typically will see one or both of these models. Obviously, I've illustrated to you very simple network designs here. We do see these types of things in multi egress networks, multiple egress points, different geographically diverse networks. If you have any questions about how we deploy Perceive, just reach out. We're happy to answer the questions for you.
Cool. One of the things I mentioned earlier is we do a bunch of, I'll call it subscriber discovery versus generic topology discovery to figure out where subscribers are, because generally in most service providers, there's no system that knows that. So we spend an enormous amount of time building that. Maybe Andy, you could talk a little bit about the information we need to prime that system, and maybe a little bit about how it works, because that often ends up being a big part of a deployment as well.
Absolutely. So Perceive is fundamentally interested in two things. It needs to have information about subscribers in terms of what their plan speeds are, who they are, what the accounts are, and it also needs information about topology. And when I say topology, I don't mean what the physical topology is. What we're doing here is that we're aggregating data to various levels of topology to help us identify where the bottlenecks in the network actually are. So from a topology perspective, there's two relationships that I'm interested in establishing. The first one is the tower to sector relationship. This is generally pretty straightforward in that most people have a sense of, okay, I have a list of all of my network sites, and at each of those network sites, I have a number of, one or more access points that I need to be that are going to be deployed there. Okay, so having a simple list of tower sites and APs that are attached to each of those tower sites gives us the tower to sector relationship. This is in general reference data. It doesn't change very often. And usually it's just defined as a static list, either in a spreadsheet somewhere or otherwise defined in your billing system. The second relationship that I need to establish in order to figure out the topology is that now I need to be able to figure out the sector to subscriber relationship. And this is a little bit more complicated in that, subscribers can move around. Equipment does move from place to place. As you're provisioning new subscribers, you need to be able to maintain that data, on a much more frequent basis than you would with the number of access points. So in terms of the data elements that we're typically going to require from a subscriber perspective, well, we're going to need to know things like subscriber IDs and subscriber names, right? These allow us to be able to search for a subscriber using meaningful data within Perceive itself, okay? You're typically going to have the concept of a package. Package is something that you sell that will have a service definition associated to it that will be typically expressed as an upload and download speed. So you'll have like a silver plan, which will be 25 by 5, or a gold plan, which would be 50 by 10 or 50 by 50, that sort of thing. And those are things that you sell to a subscriber. Then finally, you're going to have the concept of a service. And a service will typically be an individual location where the subscriber is consuming the service. there will be equipment that is associated to it. So in general, you're going to have, at a minimum, a CPE radio, which will have both a MAC address as well as an IP address potentially. And if your CPE radios are in bridged mode, well, you're also going to have a home router, and a home router will have, at a minimum, an IP address. Okay. So with that data that we're collecting, either through a spreadsheet integration or through a billing system integration, we can establish the topology. Because what we're doing to figure out the sector to subscriber relationship is that we're pulling the access point via SNMP to grab ARP entries, and then we're cross-referencing that back to the CPE MAC addresses that we're pulling from the billing system to figure out which subscribers are connected to which sectors. Okay, and in that way, we can establish the full end-to-end chain where the sector to subscriber relationship is established via this network polling mechanism, and then the sector to tower relationship is established via the reference data that is being provided by the billing system.
Cool.
Anything else you want to talk about here, Dan?
Yeah, I mean, I guess the history of that is it's as I mentioned, we put a lot of time into the topology side of things because there's an enormous amount of variation to how people deploy things, both in terms of what equipment they have, APs, switches, different deployment models. There's some standard ones, but there's also some interesting things. So it's kind of maybe the unsung hero of Perseem, I think, where it's not very sexy, but it's really important, and it saves a whole ton of manual provisioning.
Absolutely.
Cool. So if anyone has any questions, roadmap, focus, or anything, please go ahead and drop those in now. We didn't prep this ahead of time, so I'm going to see if I can stump Andy for a second. What do you have any particular learnings? Like what's the most common problem we find when we go to deploy Perseem in a customer?
Well,
And maybe it's something that's surmountable, but like what's the single most common thing that people need to have in place or think about?
Well, the most important thing that I find is that oftentimes the billing systems aren't necessarily aware of all of the data, or the network isn't modeled appropriately in the billing systems. Okay, so we talked a little bit about when we deploy in a network and having the topology information. Oftentimes there's going to be little gaps. Okay, so especially in, say, a network where you've got bridged interfaces or bridged CPE radios, and the operator is allowing the subscriber to bring their own router. Well, you're not necessarily going to have the router MAC, router IP address within the billing system. There are other things that we can do in order to discover the data plane IPs, and get them into Perseem, and to overcome some of those limitations. But oftentimes we do find that our customers, they want to make sure that the data is up to date, that is relevant, that there's a single source of truth for what the network is doing. And so, there's sometimes a little bit of an investment in having data appropriately entered into the billing system in order to get everything working.
Cool. All right, we have a question from Scott. It says, seems like most deployments would be a mix between inline and switch centric. So what do you see in current deployments, maybe in the last year, in terms of what the mix of that is?
So, like I said, people who are building a new network today, oftentimes I see this switch-centric deployment model. It just offers way more flexibility. Like I said, it scales a lot better than the inline model does. And so, new networks that we see coming in online, we typically will see this type of design. The inline models, we have some of our customers are 20, 30 years old. They've been, around since the beginning of the internet, and they're dealing with a lot of legacy. So, oftentimes, sometimes we have, guys where, the network's just been built this way. We can't really change it. We're not going to refactor the network to make it work. We have to make sure that Perseem works in that model. We also see a few different hybrid models where, let's say you've got internet, you're buying your internet at an IX, and you are, got layer 2 to all of your points of presence back to that IX. You don't necessarily have dark fiber, even though you've got an inline design. How do I build a bypass? Mm-hmm. So, we'll often see that Okay, well, just put a switch on that inline on that link, go on a hairpin, and still have a quasi inline model, but intersecting traffic using a hairpin and a switch.
Is it true? I think we'd probably see more of the inline OSPF bypass approach in smaller networks, and it's
Yeah,
probably very sufficient in that environment.
absolutely it is. And sometimes we see, where like a lot of people, they're starting as one guy in their garage and, they've just got a flat network because it's just him and, 10 people around him, where there's a router and a switch,
Mhm.
right? So, even without that layer three mechanism of OSPF, we can still bypass using a layer two mechanism like spanning tree.
Mhm.
So there are options for at large scale as well as at very small scale for deploying Proscene into the
Yeah,
network.
yeah. My experience in that case, it'd be much better to go to introduce a little bit of routing with OSPF than to do the STP thing. So yeah, just
Absolutely,
don't do the STP thing.
yeah. Layer three is definitely much more robust, but like I
Yeah.
mean, in the absence of any other gear in the network, like sometimes that's how we end up deploying.
Cool. I give a little shout out here for Kevin Myers at IPA. At WISPA shows, he's often in his sessions talking about like switch centric designs and stuff as well. So that might be a resource to look at if you're looking for more details. So next question: Will it work? Will this work on a NAT system? Uh, Andy touched on this earlier. We need to see IPs per subscriber, so we have to be inside the NAT. Otherwise, we can't distinguish what flows go to which subscriber. So
Yeah,
that's yeah. So yeah, it'll work, but deployment matters.
it does matter. Yeah, so it does work in a NAT system. We just need to deploy Proscene south of the NAT.
Yep. Next question. And what sort of switches, make, model are common for this? So what do you see people using in the last little while?
So oftentimes when we're deploying in a switch-centric design, we typically are going to see primarily older Dell switches as well as the FS.com gear seems to work really well.
Mhm.
Both are stackable in that we can just, like I said, you just keep adding to that stack by adding additional elements to it. People have tried to run this with MikroTiks as well. MikroTiks, unfortunately, are not stackable, so you're just limited by the ports that are available on your switch.
Yeah, I think the fs.com ones, I believe we have one of them, at least one of those in our lab, and that was Kevin at IPA suggested that as a decent option as well. So sounds like maybe we should have a podcast episode about switch centric design. That sounds like a really good idea.
Yeah.
Cool. All right. Well, we're up against the 45 minutes now already. So thank you everybody for participating. We'll give another couple seconds to see if anybody has any questions. Is there anything you want to close on, Andy?
No, like I said, I mean, we deploy Perseem in hundreds of, like I've deployed Perseem in hundreds of networks, from the very smallest startup layer two networks to some of the biggest regional networks that we see with multiple egress points, lots of asymmetry. We've deployed in, for entire countries at times. Um, you know, I think that it's absolutely, what we've touched on today about how we measure the QoE and how you deploy. Hopefully, this gives everybody enough information to make to understand a little bit about how all of this is going to work.
Cool. All right. Thank you, everybody. We had really good attendance. Thanks for joining us at this session and the other sessions in the ISP Summit this week. And I hope you got something out of it, and I hope you get something out of all the other sessions as well. Thank you. Bye.
Thanks, guys.